Okay, hi everyone. If you remember at the end of class, we were talking about this example 8.5. It's the cost of rehabilitation. So we said on average the cost of rehabilitation for stroke victims was $24,000. And there's a researcher that wants to see if at a particular hospital, if the average cost for their stroke victims is greater or not average, I should say. So they tested 35 people. They found that their average cost was $26,000 with a standard deviation for the population being $3,000. At alpha equaling 0.01, can it be concluded that the average cost of stroke rehabilitation at this hospital will be different from $24,000? So if you remember, we looked at all the variables and figured out what they would be labeled. Then we found the null hypothesis, which is the average population, and then the alternate hypothesis. And since it's saying that they want to know if it's not average, if it's different from average, so that's why we have our claim there for the alternate hypothesis. So all I did was copy and paste on this next slide, and now we're ready to figure out what the z-score is. So remember, we're talking about some normal curves. Our alpha here, since it's a two-tailed test, we have two tails here. Let me highlight the two areas. And we know what the area is in total. It's 0.01. So we have this area is 0.05, and this area over here is 0.05. Excuse me, 0.005. And then 0.005. All right, so you look up 0.005 on your table E, your Z table, and you figure out that the z-score is negative 2.58. There we are. And then since it's symmetric, we have that the positive z-value is positive 2.58. So then we want to figure out exactly what's going on here. So we want to substitute all our formulas, all our variables into this formula. Z equals x bar minus mu divided by sigma divided by the square root of n. If you remember, we had that up on the board on Wednesday. So we have this. Let's substitute in some variables and we'll see if we're in the critical or non-critical region. And then that will tell us if we should accept or decline the null hypothesis. So here we are. We're just substituting in the values. 24,672 divided by over the square root of 35. There we go. We do the math and we figure out that it equals 3.04. 3.04 is bigger than 2.58. So we have here that it's in the critical region. So that means that there's a significant difference. So we want to accept the alternate hypothesis. So the last part of this problem is you need to make a decision. Should you keep or reject the null hypothesis? Since we see the 3.04 is in that critical region, we're going to reject the null hypothesis. And thus we have that the claim holds. There we go. So there is a significant difference. At this hospital. All right, so that's our answer. So we want to reject the null hypothesis here. Okay, so as we move along here, we want to next discuss what a p-value is. And actually, what I'm hoping that you're doing is taking some notes here. So this is exactly what we would have in class. So the p-value, or the probability value, is the probability of getting a sample statistic, such as the mean, or a more extreme sample statistic, in the direction of the alternate hypothesis when the null hypothesis is true. So in other words, the p-value is really like the probability of getting a type 1 error when we reject the null hypothesis but it's true. There we go. And that's exactly what we were saying alpha equaled. So, let's see. So, here we go. So we want to do the hypothesis set testing here. We want to make some decisions. When using p-values. Okay, so if the p-value is less than or equal to a, then we reject the null hypothesis. Okay, so when we create this table here, if you see, like, let's say that this is our alpha, and then we find the probability, the p-value, and we have our a is over here. We would be in the critical region, and whenever you're in the critical region, you're going to reject the null hypothesis. So that's exactly what that means, reject the null hypothesis. And then here, if we have that the p-value is bigger than a, we do not reject the null hypothesis. Which also makes sense because if we were over here, let's say, then we would be in the non-critical region and we would accept the null hypothesis. All right, so we're going to work on some examples. Here, I will keep this up here for a moment. This is how you're going to do it if you're looking at the p-value. So you still state the hypothesis and identify the claim like we were doing. And then you compute the test value, find the p-value just like we were doing, compare it to that alpha, and then make the decision. And then you want to summarize the results. So let's do an example here. So here it says a researcher wishes to test the claim that the average cost of a tuition and fees for a 4-year public college is $5,700. She selects a random sample of 36 people and finds that the mean is 5,900. The population standard deviation is 659. Is there evidence to support the claim at A equaling 0.05? Use the p-value method. So here we go. We got to figure out some variables here. We got mu equals 5,700. We got n equals 36. We got our population mean is 5,950. We got our population standard deviation is 659. Now we had to figure out, we got our A value,